Okay, so now we're finally getting into some of the calculation parts for this section, okay? Most of the rest of what we've been doing so far is just understanding, and don't get too panicked if you don't understand it all, okay? Because it's kind of a little bit tricky to get. So this is the same kind of thing that you would have met back in GCSE. Properties of a wave, simple harmonic motion. If you notice, it is the same as wave motion, okay? So we can take any 2 points between that are repeating. So I could take one wavelength, it could be between here and here, or similarly I could go from here to here, and that would give me one wavelength, or I could go maybe from here to here. Okay. Main point is that they're all repeating points. I'm guessing probably not already anyway. So this is, sorry, they are not wavelengths as such because I'm not measuring in displacement. I'm measuring on my axis in time. So this is time. This is one period t. Okay. This would also be one period. So the period and the frequency are inversely related. So the frequency f is equal to 1 over t. There's the first formula you guys are going to need to know. And similarly, the period is equal to 1 over the frequency. Period is a unit of time, okay? And that's measured in seconds. Period is measured in seconds. It's measured in seconds. And of course, it's the amount of time it takes for the oscillator to complete one full cycle. Okay, so if you notice, period here is denoted as the amount of time for one cycle. In other words, one full oscillation. In other words, it has to come from the bottom all the way through the equilibrium point to the top, back down through the equilibrium point, and all the way back to the bottom again. So that's one full cycle. It goes all the way up, all the way back down, ready to go again. Okay. Now the frequency is 1 over the period. So if you notice that the unit on this one is hertz. Okay. Now hertz is really it's not an SI unit. It's really well, if the period t is the time for one cycle, okay, period is seconds per cycle, then if that's the period, then the frequency is the exact opposite of that. It's the number of cycles per second. Now, that is given the unit hertz. Hertz doesn't really mean anything. Sometimes you'll see it as seconds to the -1 because cycles is just a placeholder. It doesn't really have a unit itself, cycles. So the only actual unit that's in this is seconds, and it's below the line. So we would say it's per second or seconds to the -1. Okay. So you'll have some calculations to do based on that bit on your practice sheet here. So we've got 50 oscillations in so many seconds. So if you know you've got 50 oscillations in 43.6 seconds, then what would be the total time for one oscillation? Okay, so you have to divide that time by 50 to get the period. Once you've got the period, then you can work out the frequency from 1 over the period. Okay. So that's the next thing for you guys to do. Let me come back to our main page. So yeah, there's our relation. Period is 1 over the frequency. And if you just take a very, very simple sample question, then if you're standing on the beach and with your feet in the water, and notice that a wave comes crashing in every 4 seconds, then you're literally plugging your numbers into your equation. So this would be seconds per wave, if you like, or seconds per cycle. So then when you're getting the frequency would really have a unit of 0.25 waves per second, or cycles per second. Okay. So I'll just give that sample question a little shot. I just briefly want to finish off the last one, and I'll do it separately with the energy.